Here we are in Chapter 10, looking at confidence intervals and significance tests. I want to take a moment to practice some questions with you. I will give you the question, and at that point you're probably going to want to hit pause so that you have a chance to answer it. Some of these questions will be multiple choice, and I'll show those possible answers a few seconds after giving you the question, and then I'll work out the answer with you. Here's the first question. Take a second to read through this one and give me the correct interpretation of the interval. You don't actually have to calculate the interval, just interpret it. At this point, I would hit pause. And here are some multiple choice answers. See if your answer matches up with any of these. Let's go through each of the possibilities. Question A says, or answer A says, 90% of the students improve their scores by the interval that they gave me. Question B, very similar, but 90% of the population. Well, confidence intervals have nothing to do with probability in terms of the probability of your result being within a certain range. I'm going to have to say the answer is C. The correct answer is that you are 90% confident that the mean improvement is from 72.3 to 91.4. That a degree of confidence is given in 90%, not a probability. Now you could say the answer would be that 90% of all samples from 72.3 to 91.4 would contain the true population proportion. But really we're just talking about the range at which we think most people fall in here and how confident we are that they fall within that range. Here's question 2. Here are some multiple choice answers. See if your answer matches up with at least one of these. Your formula for confidence intervals is x bar plus or minus z star multiplied by sigma over root n. As a reminder, everything after the plus or minus is your margin of error. By plugging everything in, I have an x bar of 130 plus or minus the z star from the table. Standard deviation was 10, given to you in the original problem, divided by the square root of the sample size of 100. And when I calculate, I will get 128.355 to 131.645. So it appears that question A would have been the answer. However, I would prefer that you do not give me the answer as A or as what you see in green. I would prefer a formal sentence that expresses this confidence interval. So the full answer would be, I am 90% confident that the yield per acre for the new variety of corn will fall from 128.355 bushels to 131.645 bushels. So please write that sentence versus just giving me everything in green. Here comes the next question. This question is interested in confidence intervals and how to make a smaller margin of error, making the interval itself smaller. Here's your options for answers on how I can accomplish that. I'll give you a second to think about that on which one of those would apply. Let's go through the answers. If you haven't had a chance to think about that on your own, you should hit pause. Option A, increase the standard deviation of the population. You cannot do that. You cannot change the standard deviation's population, the population of the standard deviation, excuse me. That is not a choice. Option B, use a smaller confidence level. If I drop my confidence level from 95 down to 90, that will give me a smaller margin of error, because then the width would not be as much. So it looks like B is going to be your answer. A smaller sample size, option C, that actually does the opposite. Smaller sample sizes are going to increase the margin of error, thus increasing the interval. Here's question 4. And some possible answers. Give you a second to see if your answer matches up with one of those. Then I'll start working on the answer. Margin of error is z star times sigma over root n, and I want that to be less than or equal to 0.0001. So I'm going to plug in everything I've got to look for the sample size n that yields that result. So far I have everything you see here in orange. I'm going to do some cross multiplying to solve for n. Multiply 1.645 times 0.01. Put 0.0001 over top of 1, cross multiply. When I'm putting the variable on the left, I have to change the direction of the inequality. I divided 0.01645 by 0.0001 to isolate the n. Square both sides. My correct answer should be B. Here's question 6. Take a second to read through and come up with the correct interpretation. I'll give you the answer in a few seconds. The null hypothesis in this situation would be that there is no difference between the ethnocentrism between those who attend church and those who do not. The alternative is that there is a difference. Since our p-value is less than 0.05, our results are significant. We would reject the null hypothesis, thus favoring the alternative that there is a difference. The correct answer for this question is going to be C. We're assuming that there's no difference between the ethnocentrism between church attendees and non-attendees. So the chance that we got a difference has got to be less than the alpha level, since it's significant, or whatever the p-value is. Here's some practice on writing the correct alternative hypothesis. Let's look at our choices. I automatically can throw out option B. Because it says X bar, the alternative hypothesis is written in terms of the population. The answer has to be either A or C, because they're both written in terms of mu. These rats are hypothesized to be running faster. If they're running faster, they're going to be reducing the time it takes. The numbers that are reducing the time would be to the left of 65. The correct answer has to be C. Here is your next question. I would like you to find the p-value. I'm going to go ahead and give you the null and alternative hypothesis while I'm at it. If the company claims they can answer calls within 2 hours, I'm going to write that just as mu is equal to 2. Now I know that's a little loose since it should be less than 2, but we really always write null hypotheses in terms of equal something. For my alternative, I would assume that I'm going to go with mu is greater than 2. Direction really isn't indicated here. I could say not equal to 2, but it really wouldn't make sense to say less than 2 when that kind of backs up their claim. So I'm going to make this a single-sided test. So from all of this, I have a z-score equal to 2. Observation 2.1 minus the mean, sigma over root n. I want to look up the area to the left of a z-score of -2, or you can just look up the +2 and do 1 minus. That area to the left of -2 gives you the p-value of 0.0228. Even though it wasn't asked here, I would reject the null hypothesis at the alpha level of 0.05. I do have significant evidence to suggest that the mean response time is more than 2 hours. So that is the full significance test, even though they only ask for the p-value. A little bonus for you. Here's a question relating confidence intervals and significance tests. The answers to the options for A and B essentially are saying the same thing. In regards to the p-value, they're either greater than or less than 0.05. They're getting the 0.05 because if the confidence interval is from 95%, 1 minus that is where they're getting you 0.05. However, that's the incorrect interpretation as far as finding p-values. What that is trying to do is get you to find the alpha level. If the confidence interval is 95%, the alpha level is 0.05. The correct answer here is C. I don't know what the p-value is. I would actually have to have a sample mean, and since I don't know that, or the sample size, I can't conclude anything here. That pretty much wraps it up as far as practice goes. That should give you a couple of questions there just to think about some things. Hopefully you learned something. See ya.